how's it going? Now we're going live because this is going to be our third week learning about AI, because we're taking the path of associate AI engineer for developers. Now we finished 7 courses. Now we're going to do the 8th and the 9th course, which is the last ones. And probably the software engineering for principles in Python is really interesting because I already know Python and I already know JavaScript and C++ and minor languages, but probably it's gonna be something new. So let's just keep the path. Try to finish this. Maybe try to finish this as soon as possible, and let's see what we get. Okay, so let's start. And wait, I'm gonna check here if my audio is good. Give me 1 second. Probably it's gonna be something new. So let's just keep the path. Try to finish this. Yeah, it's all good. So let's just start. Bravazo. All right.
Welcome to the course Software Engineering for Data Scientists in Python. My name is Adam Spanbauer. I'm a data scientist from Tennessee who likes to code in both R and Python. In this course, we'll be covering software engineering concepts that can revolutionize your data science workflow. So why should a data scientist care about the principles of software engineering? Many data scientists, like myself, start in the world of math and statistics. And soon after, you learn that communicating these technical ideas is just as important as understanding them yourself. However, many data scientists are self-taught programmers who see coding as a means to an end. It's just a step to create a model or run a simulation. But in reality, software engineering is a valuable skill that needs to be learned and practiced. This course will help build your software engineering skills by introducing some very important concepts. 3 topics in particular that we'll cover are modularity, documentation, and testing. Another topic worth mentioning is version control. We won't be covering it in this course, but I recommend checking out the related data camp course to learn more about this powerful tool. Let's define each of these concepts that we'll be covering. First was modularity. To introduce modular code, let's start by defining what it's not. Non-modular code can take the form of long, complicated, hard-to-read scripts and functions. Programming becomes less complex when your code is divided into shorter, functional units, and this is the whole idea behind modularity. With modular code, not only does code become more readable, but it becomes easier to fix when something breaks. Additionally, modular code is easier to take along with you to your next project, which allows you to save time by avoiding resolving problems you've already solved in a previous project. We can write modular code in Python by leveraging packages, classes, and methods. In this example code, we import the pandas package. We create a new object using the powerful DataFrame class from pandas. Finally, we use the convenient plot method that comes built into the DataFrame class. Later in this course, you'll write a fully functional Python package using all these concepts to perform text analysis. If you work on a team, or if you ever publish a project, then other people will need to read your code, and sometimes the other person is just future you. Both future you and other people will have an easier time reading your project if you use good documentation practices. In this course, we'll cover how to use comments, docstrings, and self-documenting code to document your data science Python projects. A project using all these techniques can save a lot of confusion and frustration for everyone who touches the code. The last software engineering concept we'll touch on is testing. One thing everyone learns is that people make mistakes. That's why pencils have erasers, why computers have spell check, and why software needs tests. Oftentimes, data scientists will write some code, test it in the console once, and then never test it again. It's definitely worthwhile to perform these manual tests, but leveraging tools like the PyTest package can automatically run and rerun your tests to ensure your code is working as intended even after adding new functionality. Okay, we went over some pretty big topics. Let's do some exercises to review.
All right. So, which 3 software engineering concepts included in this course can help data scientists save, collaborate, and write better code? Modularity, documentation, and automated testing. All right, let's see here. For some reason, my computer is kind of slow today. Since we covered 3 ways to you write model for the packages, classes, and methods. For reference, you can see the example code we reviewed below. Okay. class and method from the popular. Okay, so here is numpy. Here's an array. Here is array.sort. Yeah. Let's submit. Now let's go into here and let's make a folder. Okay, and now here we're gonna do first, this is called Python modularity. File one. I am under the impression that I already know all of these topics. Let's just use max 30 minutes to finish all of this, okay? Or maybe I'm wrong. Maybe there's something new here. Interesting. The packages and documentation.
You've now learned some important software engineering concepts. We're now going to look at how beneficial these concepts can be as a user of Python open source software. Namely, we're going to investigate packages. We'll cover how to install packages from the Python package index, and we'll see how these packages leverage software engineering concepts we've covered. Later in the course, we'll talk more about the Python package index, or PyPy for short, but for now, all you need to know is that PyPy gives us an easy platform to leverage published packages. Thanks to packages being modular, we can easily install them from PyPy using a tool called pip. Pip is actually a recursive acronym that stands for pip installs packages, and it does just that. The practice of leveraging pip install can save a lot of time and lets us avoid reworking problems that have already been solved and packaged by some smart members of the Python community. If we wanted to install the popular package NumPy, we conveniently use the command pip install numpy. Barring any unexpected issues, we now have NumPy installed, and we can leverage all the benefits that come with this powerful package. Note that pip will also install a package's dependencies as long as they're on PyPy. However, in some cases, a package's dependencies might require a little extra work. So how do we leverage NumPy's features? Again, thanks to good software engineering, NumPy has excellent documentation available both on the web and in the package itself. Here, we'll focus on the documentation shipped with the package. Let's say we want to count the number of workdays in the year 2020. NumPy provides the function busDayCount that can help us accomplish this. But how do we use it? To view a function's documentation, we can use the function help. Here is the syntax we can use to learn more about NumPy's busDayCount method. And here's the response to our call for help. Note that the output has been truncated. From this documentation, we see a description of the function, its parameters, and what we can expect as output. Additionally, we see an example that perfectly matches our described use case.
Okay, that one didn't know.
We just saw that we can use help to see a method's documentation, but we can also call help on any object in Python. We can call help on the NumPy package to see some high-level documentation on what functionality it provides. And here, we call help on a number. From the output, we can read up on Python's integer class. As you can probably tell, having this documentation can be invaluable to users like you and me. But sometimes, you might call help on an object and see that there isn't any documentation. It's up to the developer to include these helpful tidbits. Including documentation for your packages, classes, and methods will make using your code much easier. It's important to remember that future you is also a user who will benefit from this documentation. Believe me, documenting your code, even if you're the only user, can save a lot of wasted time and headaches. I've personally suffered through relearning how to use code that I wrote, but this is totally preventable with good documentation. Okay, we covered how to pip install packages and how to read documentation using help. In the following exercises, you'll get to practice both of these invaluable skills. Good luck!
Which of the below commands you could run in your shell to install a package numpy with pip? Pip install numpy. Yeah. The writing codes neededly is not use someone's as you'll learn expectations called much more pleasant when they use code summary in particular good documentation makes it right away to execute. Python's help method to view function documentation so you can determine how correctly call a new method. So we can do here help. We can create to oh no. Okay, we save this. we do here 2, and then here we do, what's the name? How much? How method. So we copy this. Correctly called. List words. Most common. Here I should do 5. And here we're gonna do the leverage documentation. Most common. But if I write Python 3 words, I use class for this file. For this file, please complete. Variable. All right. Conventions and PEP 8.
Great work on those exercises. In our short time together, we've seen how helpful the Python community can be. Not only have they provided some excellent packages for us to use, but they've also provided documentation to help us use them. Something you probably know from real life is that different cultures and communities follow different guidelines that can help them run smoothly. For example, this can be seen in different greetings. Depending on which community setting you're in, it might make sense to say hello by shaking hands, bowing, or bumping fists. These unwritten rules are known as social conventions. The world of software engineering also has conventions that differ based on language and community. Luckily for Pythonistas, these conventions aren't unwritten. We can turn to Python Enhancement Protocol 8, or PEP 8. PEP 8 is the de facto style guide for Python code. It lets us know how to format our code to be as readable as possible, and to quote PEP 8, code is read much more often than it is written. So readability is not something that should be overlooked. Let's see an example. Here, we have some code that violates PEP 8 best practices. To put it simply, the code here is hard to read. A few problems are, the module import isn't at the top of the file, the spacing and indentation is inconsistent, and the lack of line breaks makes it difficult to tell when one idea finishes and the next one begins. Even without knowing the specific PEP 8 rules being broken, you can probably tell this isn't the most readable chunk of code. Let's see what the same chunk of code looks like after being rewritten to conform to PEP 8. Much better. By following the agreed upon rules in PEP 8 and using white space appropriately, this code became much more readable despite accomplishing the same exact task. So how is it possible to keep up with the many rules defined in PEP 8? Thankfully for you and me, there are tools that can check your code for you just like a spell checker. Personally, I use an IDE that flags violations as soon as I write a bad line of code, but there are other options. One in particular that you'll be exposed to in this course is the PyCode style package. PyCode style can check code in multiple files at once and it outputs descriptions of the violations along with information to let you know exactly where you need to go to fix the issue. Here is some example code on how to install and use pinecone style from the shell. As you'll see in the exercises later, you can also run pinecone style from a Python script. Here we use the command line interface to check the contents of the file dict2array.py that contains our poorly formatted code from before. Note that the output we see on this slide has been truncated. The output shows us the exact location of any violations by showing the file name, line number, and column number where the problem occurred.
This is something like prettier in the JavaScript.
Note that the output does not use zero-based indexing. Additionally, pinecone style outputs a human-readable description of the PEP8 violation and an error code. A complete list of pinecone style's possible error codes can be seen in the package's documentation. Okay, we've covered the importance of PEP8 and how it can improve your code's readability. Let's move on to some exercises to get some hands-on experience.
Okay, we saw earlier that pinecone style can be run from the command line to check a file for PEP8 compliance. Sometimes it's useful to run this kind of checking. So I need to run the pinecone style. I need to create an instance of a style guide. Name is style checker. Check files. And then they need to check into these two. And I see the errors there. Let's rename these to 4 using pinecone style. Okay. Now let's run this tree again. Sample word list. You didn't want to complete this. Okay. Let's do this now. Let's continue. Conforming to PEP8. Missing white space. So as we cover. Okay. Okay, so now I need to edit this code so it's compliant. So and the line 2 missing white space around operator. So it's like this. And the 2.7. This is better. In this 2.7, I don't know what's. There's more? Missing white space after comma and after comma. Oh, okay, I thought that this was a quote. Okay. And here so far we focus how PEP affects functional pieces of code. These are also rules to how to make comments and documentation more readable. You'll be fixing various types of comments by PEP8 compliant. Okay, in line 2, I think is at least 2 spaces before inline comment. 2 spaces before inline comment. in the line 5, inline comment should start with space after the hashtag, and then in the 11.1 block comment should start with a space after the hashtag. Indentation is the multiple of 4. So this is 13.2. Okay, because here it's weird indentation. And 13 inspect indentation comment. Okay, now it's good. Okay, how long are we streaming? 20 minutes. Okay, let's take a small break and we come back in a second. Okay?